This video covers information on scatter plots and correlation. Up until now, we've been studying univariate data, and now we're going to move into bivariate data, which is the analysis of relationships between two data sets. Most of the time, we use scatter plots to investigate the possible relationships between variables that both relate to the same event. So one characteristic that we need to talk about is the correlation, which is the actual relationship between two variables. The first way that we can describe the correlation is using direction. So it can be positive, y increases as x increases. It can be negative, y decreases as x increases, or there can be no correlation. The second way you can describe the correlation is through the strength. You could have strong, moderate, or weak, but not every relationship is linear. Many things are not in real life. On the next slide here are some graphs that represent the different strengths and directions of correlation. So the first ones here, these are both strong. Top is positive, bottom is negative. The second ones here are moderate, so you can see the points are still together in a trend, but not quite as close as the first one. Again, the top is positive, second is negative. The last ones represent a weak correlation, where the dots are loosely grouped together. You can also have causation, which is that the fact that a correlation between two data sets doesn't necessarily mean that one causes the other. For example, a grade school student's shoe size versus their vocabulary. You can compare those variables all you want. It doesn't necessarily mean one influences the other. In order to quantify the correlation, we look at the R value, or the Pearson product moment correlation coefficient, which is a measure of the correlation between two variables, and it gives a value between +1 and -1. A perfect correlation is R equals 1. So in the physical sciences, usually you want a confidence level of 0.01 or better, which means R equals 0.99 or higher. That way you can confidently say that it is a linear relationship. So the values that correspond to the quantifiers of correlation, this is also on page 326 in your textbook. So an R value between 0 and 0.25 is very weak. Between 0.25 and 0.5 is weak. 0.5 to 0.75 is moderate. And then anything above 0.75 would be strong. This first example shows the average weights for given heights in a population of men, and we've got three things to do. The first one is to determine the R value, then to describe the correlation, and then finally to interpret the correlation between average weights and heights given. This is a very common question on IB exams, so you should be familiar with doing this on your GDC or your emulator, whichever you're using right now. So following the instructions below, you can see the screen capture also linked in the unit outline. You should be able to determine the R value and describe the correlation. So for me, the R value is you should get 0.997, which is a strong correlation. And in order to interpret that correlation, we would say as height increases, weight also increases. Down below are some practice questions on determining the correlation of different relationships.